Hello, everyone, and thank you for listening to the Fabrication Friday podcast. I'm your host, Joe Fairley, certified prosthetist, 3D printing enthusiast, and owner of Ascent Fabrication. Fabrication Friday is an all-around fun time where I talk about 3D printing applications, conduct interviews with industry leaders, and much more. Come join us every Friday for an informational discussion around the evolution of the additive manufacturing field and how we utilize various digital workflows and 3D printing methods in our daily work at Ascent Fabrication. Hello, everyone, and happy Fabrication Friday. I am your host, Joe Fairley from Ascent Fabrication, owner and certified prosthetist. Ascent Fabrication has really been on a good clip this week with printing out a lot of lower extremity orthoses, actually, particularly on our Raise 3D Pro 3 Plus. We like the Raise 3D Pro 3 because it has a huge build volume of about over 24 inches, I believe, and then dual extrusion. So we're able to print polypropylene on one side and a support material on the right side, giving us a lot of freedom to print out some really hard to print shapes. And that's with PP Prints polypropylene. If you want to learn more about their material, check out their colors, go to our website, ascentfab.com, and check out that material. We'll even send you a sample kit for free. So just drop us a line in an email or on LinkedIn, or otherwise give us a call and we can send you out a free sample kit. Today, I'm pretty excited to have Nicki Chamberlain-Simon here. Nicki and I have known each other now for a few years and have worked on some projects on and off. I think we were maybe back in 2017, 2018, or yeah, no, it was actually 2018, 2019 when I was just graduating from Northwestern MPO program, their Prosthetics and Orthotics school there, and Nicki was coming in. So Nicki is a certified prosthetist orthotist, and very happy to have her on today.
Yeah, thanks for having me, Joe. We've teamed up on a few things, and I think I might throw some questions back at you because we'll have similar experiences.
Yeah, for sure. We've got similar interest in P&O, obviously, but also on the 3D printing side of things.
Yeah.
So how did you first learn about 3D printing and get involved with 3D printing in general?
For me, it was back in college. I studied bioengineering at Rice University in Houston, and everyone does a senior design engineering project, which was super awesome. Really, really cool program that they had. And I ended up working on a team of, it's actually 5 females who are still like some of my best friends today. And we worked on the carpal diem team where we teamed up with a surgeon, a hand surgeon at Shriners, to originally do an enable hands project until we started kind of looking into what the project was going to look like. And we realized that the hands actually didn't work super well. And so instead we developed a testing device for enable hands. So through that project, we printed out a couple enable hands. We used really basic FDM printers that we had access to at the Rice, it's called the ODEC, the Engineering Design Kitchen. And we also were able to 3D print some parts of our testing setup. So we printed out these little, one was a cylinder, one was a pinch device, and one was a multi-sided sphere. And we instrumented them with different sensors. And we were able to like print them out and have slots so that the sensors could go through them. And that was definitely my first introduction to 3D printing, and very quickly fell in love with it and knew that I wanted to do 3D printing in any capacity that I could moving forward.
Yeah, that's extremely similar to my beginnings in prosthetics and 3D printing in general. Had a senior level project in my undergrad here at Siena College in Albany, New York, and My mentor said, there's this 3D printer thing over there in the corner collecting dust, figure it out and do something with it. And at that time, 2015, Enable was really starting to gain some traction. I think what they did really well was to create a community around
Yeah.
understanding some, limb differences within kids. Having that kind of courage booster for them, I think they did really well. Absolutely, there were some problems with the mechanical functions of the hands and maybe some of the clinical thought that was not present within their first introductions to actually working with people, working with technically patients. So there were definitely some head butting going on there, but I think Enable has kind of created this general interest in 3D printing in a lot of people across the country.
Yeah, and I know some of my other classmates had involvement with the Enable Hand project, and the whole open access idea was super cool. Like that's
Yeah,
what I think everyone got so excited about. Some would say it got taken a little bit too far because then you have these
sure.
hobbyists printing hands for patients and sending them to them and no one knowing what to do with them.
Right.
But yeah, the environment of it was cool, especially for a young engineer.
Right. Yeah, it's a little different when you're working with a prosthetist versus someone here in the US or someone in the UK printing it out and then shipping it to Africa to a kid, right? It just doesn't quite work that way.
No.
Although they kind of blew it up to be something similar to that. But yeah, with those hands, do you remember what printers and materials you were using to print those?
Yeah, well, I think so. This was several years back. So most of it was with an FDM printer. Oh boy, I want to say it was a Prusa.
Okay,
Um, it was very much a hobbyist printer. It wasn't
sure.
like a desktop. It was something that was completely open and had screws that you could still be screwing in. It might not have been a Prusa, but honestly, I don't remember which one it was.
Yeah.
We're printing almost exclusively in ABS
Okay.
standard. And then we also printed a couple things on, I want to say it was an MJF printer that they had.
Oh wow. Okay.
And that was because we were printing those complex shapes that had the gaps for the sensors to go through. And so we
Yeah.
wanted to be able to put it in the solvent to get rid of the infill material.
Sure.
But that blew the majority of our team's budget. So
Yeah.
that was like at the very end of the project when we're like, well, we have this much left and it's all going to print these three pieces.
Right. Right. I didn't even realize that MJF was really around, back then. What was this, 2016, 2017, maybe?
2016,
Yeah.
and I kind of want to go back and check which printer they had now.
Yeah.
I don't know if it was MJF. It could have been one of those like the J180,
Sure.
bunch of number
Yeah.
printers. But whatever it was one of those massive printers that I was not allowed to work with it. I had to send my file to someone and then they had to print it for me.
Right.
And it was, I mean, I can't even show you wingspan
Yeah.
of how big it was.
It's like 3/4 the length of a car, right? It's
Yeah,
yeah, they're pretty big.
yeah.
Um, well, that's neat that you kind of, intertwined those two different printing processes, with each other back then, because I feel like that, again, it didn't have that much exposure to even to the US. I think they were doing a lot more SLS in Europe before
Hmm.
they did any kind of SLS here in the States. Maybe Stratasys. I could be misquoting that. Stratasys might not do any SLS, I forget, but one of the larger companies, industrial printers, I know was doing some SLS printing here in the States. But yeah, I think it was a little while before like Form Labs really came on and got
Yeah.
into like more of the economy style sort of SLS printing. But oh, that's pretty neat. So once you graduated from Rice and you had that experience through 3D printing these hands from the Enable designs. Kind of where did you go from there?
Well, so that project did spark both interest in 3D printing as well as interest in prosthetics. And I had gotten interested in prosthetics like end of my junior year of college, had started shadowing in Chicago. And so right out of college, I was debating if I wanted to go directly into the clinical space for prosthetics and orthotics, or if I wanted to go on kind of an R&D, more of the engineering side of it. And so I thought a great, I don't want to say time filler, but something to kind of give me a sense of what the research side would be like would be to do a fellowship. And I sent out a bunch of emails to my professors at Rice asking for, I thought I'd go really specific. I wanted a prosthetics project that was ideally low cost, that was in a Spanish speaking country. And someone replied to me like a week later saying, yeah, I run a program in Costa Rica actually, and there's this person who works on this project that's exactly that, and I'm going to connect you with them. I had a conversation with them, and they were like, yeah, come on over, especially if you can get this fellowship to come here. Great. So I moved to Costa Rica for about a year and a half and worked on initially, actually, the project was a low cost 3D printed prosthetic project, but ended up more being a high fidelity additive manufacturing prosthetic project.
Okay.
Because we quickly realized that the printer that we were working with, which was primarily the Markforged printer, which I know you have a lot of experience with too, Joe.
Yeah.
It has continuous filament fabrication, which is their processes and their technologies continue changing, but this is what it was back in 2019. They have nylon filaments that have a core of carbon fiber, and you're using essentially FDM technology, but their proprietary printer to print carbon fiber I wouldn't say infused, like a strand of carbon fiber inside of nylon and printing strands of that. Right. And then you can also, what we would do is print kind of a shell of nylon, and inside that have those nylon carbon fiber fibers. So I was responsible for the socket portion of that study. There was someone else working on the pylon, and there was someone else working on the foot. And the socket was tough. I mean, especially as someone who had maybe, I don't know, 50 hours of shadowing experience at the time. Yeah. I was the one who was supposed to have the most clinical knowledge about this, and which is to say very, very little. I ended up working a lot with one of the prosthetists down in Costa Rica. I would drive from Cartago, the city that I was living in, out to San Jose, which it's about an hour commute on a bus, and then I'd walk about half an hour to get to his office, and then I'd shadow for about half the day and then go back to the lab. And his name is Oscar Granados, awesome, awesome prosthetist. And I got pretty much all of my clinical knowledge from him, and then tried to implement that in building a socket using, we scanned this one patient, modified the socket using Mesh Mixer, and then, or I guess modified his limb, built the socket using Mesh Mixer, then passed it over to the Markforged slicing profile. I could go into that, spend hours and hours on that platform, because ultimately manually made this process where I would switch off between nylon and carbon every layer, and you had to do it manually at the time.
Yeah. Yeah.
And I think it was like, I don't know, 600 layers or something. And then ended up having to print my socket in 2 pieces because the build height was too small.
Right. It's about the size of a shoebox. For anyone who doesn't know the Markforged printers, The Mark II is about the size of a shoebox, maybe a little bit taller than that kind of build volume.
Yeah.
So printing a prosthetic socket, especially standing straight up, you're really not going to get anything going on there with that kind of build height. It might have like 8 inches, maybe 8 inches of build height. It's a really quite unique printer, and what Nicki mentioned, how it lays down actual continuous fiber strands. And then with the nylon added after the fact, so that you're basically, like she said, sandwiching those physical continuous strands of carbon fiber or fiberglass in between the nylon acting like a glue, holding it all together basically as just an interface. Came up with some pretty unique try to workarounds to print out a socket, right?
Yeah.
Did it kind of look the same for the pylon and the foot, or how did that go?
No, each one was very different, which was kind of fun because we all worked in the same lab. It was me and Miguel and Nacho, and it was the three of us really worked on this project with some other undergraduates who were actually contributing a lot to the project as well. But so mine ultimately was very much a multi-material design where it was nylon in the non-load bearing surfaces, and then that carbon fiber in the load bearing surfaces. The Nacho was working on the pylon, and he ended up printing it in onyx, which was, instead of continuous carbon fibers, it's that chopped carbon fiber material.
Right.
And it comes out as a bit rougher, but it's I guess you'd call it I am losing my vocab here, but it's all the same filament being printed out, but
Right.
it has multiple materials within it.
Right.
And then Miguel was working on the foot and ultimately printed in fiberglass and nylon.
Yeah.
Nacho was really focused on looking at the mechanical properties of the material. So he was also working with some really cool matrices. That, I think that was probably the most interesting to me. And then Miguel was doing a lot of parametric modeling and SolidWorks, and then sending his foot to Nacho to do mechanical testing and experimenting with different J shapes and different designs. So yeah, we all were kind of working on different parts, and then ultimately built it together into one prosthesis that this guy used briefly, actually, because he unfortunately passed away soon after that.
It's tough sometimes when the health aspect of things comes into it with the patient care. But what Nicki also didn't quite yet mention is the fact that I was at the same time working on a 99% similar project.
Yes.
With here in the US, not in Costa Rica, but it was kind of started back in 2017 when I started looking at other things that we could 3D print after this Enable project started. And I really wanted to focus on a foot. I was interested in running, and so the foot to me was like that really key part. Could we 3D print a prosthetic foot that would allow enough energy return to be considered, for high activity use? So over those 2 years, from 2017 through 2019, I worked with a friend of mine from the Victoria Hand Project, Joshua Coots, as well as Henry Warder. Henry had worked for Nia Technologies for a period of time, went to Africa, did some cool 3D printing prosthetics with them. And he was just very interested in what I was doing. I think I got in touch with him through Enable as well, actually. So all these connections are revolving back around Enable. But yeah, we were doing the exact same thing with a Markforged Mark Two printer, coming up with a prosthetic foot design that could either be printed in carbon fiber and then nylon, or fiberglass and nylon, and we were comparing the characteristics mechanically of both of those two materials. Ultimately, we also printed out a pylon, which did not work so well. It was not rigid enough for what we needed it to be.
I will say the quick conclusion of our project, which was not great for Nacho, was that the aluminum / titanium pylon is the best solution for right now.
It is. And that's just part of 3D printing, right? It's like, what is the best use case? Sometimes just because you can print it doesn't mean you should.
Yeah.
It just doesn't work out the same. Those forces end up taking over, and those materials or the printing process just simply is not better than what is already out there. So that's one key feature that I think I've learned over the past 8 years of being involved with 3D printing. But yeah, we ultimately ended up working with Nicki a little bit on that design as well for the final foot, and doing some foot testing through the AOPA foot project.
Yeah.
Ultimately, we found that we could get dynamic energy return, as it was categorized. Over 75% of the energy that was put in would have to come out in order to be termed dynamic energy returning as a prosthetic foot. We did a lot of that research through Duke University, where Henry was at the time finishing up his biomedical engineering bachelor's, I think, something like that. Ultimately, Henry and I ended up writing a patent for it. We have this patent that involves a whole lower limb prosthesis to be printed through, more vaguely, continuous fiber fabrication. So having continuous fiber strands, and now there's another company out there, Aniso Print, that also does very similar type of printing. And we can print out, the socket. We could print any of the other componentry. Particularly, we do mention metal in the patent as well, that some of those components can be printed in metal. And then the foot being printed in a fiberglass or carbon fiber material. So that's been pretty cool to see that, development. And when we were at Northwestern and we met, that was one of the first things we led off with, and the light went off, right?
Yeah, it was uncanny, really. I mean, I started talking about the project and you were like, no way I've worked with that printer, and no way I've worked with that material, and no way we've done that testing. So yeah, it was like, yeah, I'm gonna keep in touch with this guy. Yeah. So I also was just so mind blown that you guys went through the patent process. That was something that people sometimes talk about in prosthetics. It just seems like so much work, and it's a weird field to go through the patent process, because everyone's kind of inventing constantly, and there's so many different iterations of different things. Actually, my parents got me, I'm gonna just show this because it's pretty funny. My parents got me this old prosthetic limb patents from the 1800s and 1900s poster.
Oh, that's cool. Yeah.
And this is pretty wild to look at, because it's like a full prosthetic limb, full prosthetic arm, and full prosthetic hand, with the mechanical components. And it kind of seems like people used to go through the patent process more than they do today. I don't know if that's true or not. I actually have no idea. But I'm curious, Joe, how many hours do you think you all put in to get that patent together?
I mean, ultimately, from the time that we started going through, how do you submit a patent? What's that process? What is a provisional patent? You actually have a year of a provisional patent before you even have to file for a full patent. We went through, from 2018 really was when I think we started to get serious about a patent, and then we didn't get it until I think 2021. I'll have to go back and look at the records. I might be a little off on that, but I mean, over the course of 3 years, we spent hundreds of hours on that. I mean, if I'd like to share this episode with Henry because he'll chuckle at this, where Henry and Henry came out to my house here in New York one day because we were getting down to the very nitty gritty of writing the patent. And obviously, three young, somewhat older kids, wanted to write a patent together, but didn't want to spend $10,000 hiring a lawyer to write a patent.
Really?
Who would have thought? So we, Henry came out to Saratoga and we sat down, and just the entire day was spent physically ourselves writing the patent and referencing other patents and what vernacular do you use? What kind of jargon are you supposed to put in there? Oh, you have to have all these very descriptive drawings like Nicki just showed. So Josh was actually the drawing expert on that side of things. He was a mechanical engineer by trade, and so helped us out with the drawings. So he did all the drawings. We actually wrote the patent and we sent it to our lawyer. And he said, wow, this is a great start. Let's edit a few things here and there, but that's about it. Like, you guys did a great job of, writing this out in pretty good, jargon. So, we spent, probably a good week on just initially writing the patent and editing it to get it ready to submit. And then it was a 2 year, maybe 2.5 year waiting period of, okay, when do we actually have someone to look at the patent? When do they even have time to do that?
Yeah.
Okay, they've looked at it now. They have some questions as to how similar it is to other patents. So they give us these other patents to look at. And we did a lot of research beforehand to make sure that if we were going to try to submit a patent, that it was going to be worth it. And we were really confident going into it that no one had done anything like this yet. Because nobody had, specifically with, this form of 3D printing, it's not just the design of the foot or the knee. We can use any particular design for those. It's just the process of getting to that point, using these specific methods of design techniques to slicing techniques and different printing techniques to get to this prosthesis, because we felt that was going to be the best chance of a prosthetic foot being able to be used like that in the field. So yeah, a lot of time and effort went into it over the course of about 3 years, on the cheapest budget we could possibly put into it. I think ultimately, we might have ended up spending between $6,000 to $8,000, somewhere in there, overall on lawyer fees and submitting it, and the entire process of the materials and the time. Markforged did help out quite a bit in the beginning, before they were a public company. So they were just getting started, really, and gaining traction, and they helped us out with a lot of donated materials, and we were going through a case study process with them, so that was pretty neat. So thank you to Markforged if anyone from them listens to this. I just recently, last week, actually met someone from Markforged, who was at the Rochester Institute of Technology additive manufacturing symposium that I spoke at, and he was in their metal printing division. So
Gotcha. Yeah, it sounds like their baby right now.
yeah. What do you know about metal printing so far? What's your impression of it?
What do I know about it? Not a ton. I'm mostly familiar with Markforged metal printing, because it was when both you and I and Henry were trying to get Markforged continually involved in this prosthetic foot project. They were very quickly veering off to other industries and other technologies, as companies do. And so their metal printing, I mean, correct me if I'm wrong, but I believe it's kind of a sintering process. And so they have these metal powders, that they go layer by layer and fuse together with, I don't know how hot, but I would imagine very hot.
Right.
And when I'd spoken with someone about it, and I guess the really secret sauce about it is that with the metal printing, you have a lot of dimensional changes as you're printing. And so
Hmm.
they had to figure out this perfect formula of if this is the CAD file that you're sending and it's being sliced this way, it has to be printed at this dimension, and then we know it's going to, I don't know if it's either shrink or expand to this dimension.
Yeah, it ends up
Um,
shrinking quite a bit, actually,
yeah.
which was surprising to me as well. Yeah.
And yeah, metal printing, I think, is very useful. Sounds like it's going to be a really big part of many different industries. I have not seen it come into the prosthetic and orthotic industry yet at all. I don't know exactly where it would fit in because that pylon, that's where we get a lot of our
Yeah.
metal parts. You have your components too. But right now there isn't a lot of push for having those really custom components, but that's probably the biggest application. Like I don't see
Yeah.
a metal printed foot coming out anytime soon. It'd probably be too heavy,
Right.
too rigid.
Yeah.
Um,
So
yeah.
I do know that Point Designs actually they 3D print their fingers. Uh,
Oh,
yep. So those are metal printed. I don't know if they're titanium. I think they're titanium. But yeah, Point Designs they come up with some um, really nice silicone interfaces as well for partial hand, partial finger solutions.
mm,
Um, they have now one of their own 3D printing gurus, Chris Bashuk, who I've followed for a while now. They're making some really nice 3D printed MJF frames for the socket to go with the 3D printed fingers. So yeah, they're the only instance that I know of any kind of product that's metal printed in the industry. Metal printing, from how I know it, is just still a little too costly for
yeah.
slightly larger objects. So alignable componentry, certainly it could be 3D printed. There's nothing stopping that really other than the price of it per component. I think it's just probably going to be a little too high. But we're gonna kind of investigate that a little bit with Markforged here in the future.
Mm.
But yeah, with your involvement as well with the foot project that we went through, with Henry, what was your impression of that at the time? And can you just, for our listeners, kind of give them an inkling as to how you were involved there?
Oh, sure. Yeah, I mean, the technology seemed extremely feasible to me. The concept of having printed fiberglass encased in essentially a nylon shell, similar to what I was talking about before, it had a lot of the right properties. It was relatively flexible and responsive while being pretty durable and very unlikely to catastrophically fail. I feel like that's one of the big things about it with any, not any, but most FDM parts, PLA, ABS, those kind of hobby materials. Some people will print feet using, let's say, ABS, and what's going to happen is those are just going to snap.
Hmm.
And no one wants that to happen, right?
Right.
You're making a prosthesis, you want it to be safe. That's like the number one hope and need. And with fiberglass and nylon, you're at least dealing with something that I think can be safe. The weight, I think, is pretty ideal. You're not making something that's super crazy heavy. Um, it gets really complex when you start deciding where you're going to put these fiberglass filaments and how much you're going to use. And then it all changes based on body weight, length of the foot. I mean, every foot manufacturer, they're going to give you that chart where you're picking
Right.
what's your activity level, what's your patient weight, and what's the length of their foot. And that takes a lot of work, a lot of testing to figure out, especially when we're not just talking about changing the dimensions of something. we're talking about changing the dimensions as well as every intricate filament that is wound throughout that part. And to say that there are millions of iterations, I mean, there's billions. It's infinite, really, of how many iterations you can have. So I feel like that part really needs to get there for this to be something that people are comfortable using. We have to get to the point where my vision of this, I hope either I work on this, someone works on this, is that we get to a point where we can parameterize these designs, where all you have to do is input someone's height, weight, foot size, activity level, and then you can produce a model of what your foot is going to look like that's pre-sliced.
Right.
We're not there at the moment. But the other, I think, big issue that we were dealing with was layer adhesion, especially between the fiberglass and the nylon shell.
Mm-hmm.
So we had some different strategies for dealing with that. That was actually something that I tried to bring from our Costa Rica project to you and Henry, was that we found much better layer adhesion when we had alternating just nylon, then nylon fiberglass, just nylon, nylon fiberglass, instead of having this encased fiberglass altogether and then just nylon altogether.
Right.
And I think that does help, but that when we started implementing that is when we were, I guess, really trying to find some cheap options for mechanical testing, and it is not cheap.
No.
And we all exiting our institutional settings, and when that happens, it gets really tough. So
right.
I think, yeah, if we can do some more testing like that, then we could keep developing it, but without having the testing capability, it's really tough to get it to the next level.
Right. Yeah, we had done some testing cyclically of one of the feet, simply because one of the prosthetic manufacturing companies was interested in doing that with us. So it lasted about only a month's worth of someone actually walking on it before it showed those signs of delamination of the nylon, really.
Yeah.
So a lot of work to be done on that side of things with design and some of those, designed for additive manufacturing techniques. The slicing is completely involved in that as well. How you route the fibering, where you route it, how you orient that part on the printer. So yeah, thank you for your, involvement back then, and, looking forward to hopefully having you back into it here in the future.
Yeah. I will actually, I should mention these because I think they're interesting little tidbits. When I did start that project in Costa Rica, one of the cool parts is it started with an assessment of our existing, not just 3D printing, but additive and reductive manufacturing materials that we could potentially work with. And so we ended on the Markforged technology, but we looked at two other materials as well. One was Formlabs SLA, so resin printing, and found that material, the materials of the mechanical properties of that material are insane. We did compressive testing, and it doesn't break. I don't remember what force we got up to, but
yeah,
you can apply massive amounts of compressive force to that material and it does not break. Now, tensile properties, you're talking about a different story. Also, it's a resin and resin-based material, and so UV properties, it has to be exposed to the sun. Yeah. So it wasn't something that was really feasible to use. We also looked at this technology called, it was CBAM, composite-based additive manufacturing. I don't even know if they are still in business now. I hope so. I think they probably are. But they did reductive manufacturing where they had these little thin carbon fiber sheets, and they would lay a glue-like material on top of the sheets, stack up a whole bunch of those sheets, and then use it was some nutshell blasting to then remove all of the sheet material that didn't have that glue on it.
Interesting. Okay.
Yeah, and we tested that material as well, and in the end, it was actually had pretty impressive mechanical properties. It was definitely more brittle than the nylon fiberglass combination, but just way too expensive. Way too expensive, too small of a build volume.
I might have also have met them at RIT's Additive Manufacturing Symposium if it's the same people, because these people had this large printer that was more of a like assembly line process where they would take the carbon fiber sheets and they would lay them down specifically and orient them right on top of each other, and then lay down some kind of bonding in between, and then they would go over with a laser and cut out where they were going to actually have the part. They could really small build volumes, but they could produce 50 parts in like 5 minutes. So that's what was impressive to me. It might be similar, or it might be the same people that might have changed their processes a little bit, but it was super interesting to hear about that kind of additive.
Yeah, so I'm actually looking it up right now. I haven't checked in on them in a while. The company's called Impossible Objects.
Yeah, that was them.
No way. So they are based in the neighboring neighborhood of where I grew up.
Oh wow.
And when I was in Costa Rica, they were looking into this material. I don't know how they even found them. And I looked it up and I was like, oh my God, I'm gonna go home to visit my family, and then I'm gonna go talk to them.
Right.
And so I was this like fresh out of undergrad person going in and talking to these people and asking them about their processes and telling them what we were using it for. And it was really cool because I got to speak with one of their head engineers and talk about their development process. Very cool company. And I'm glad to see that they're still at it and going strong.
Yeah, they have now a printer that's coming to market, actually, I think in the fall, they said. Maybe I should reach out to them and have them on the podcast at a later time to see kind of what they're up to. Super interesting type of additive manufacturing. I didn't even really kind of consider that, but when we talk about carbon fiber in general, with the strength really being in like the interwoven layers, that's one way to do it. You've got sheets of this interwoven layer material already that you're adding on each other, and then using some subtractive manufacturing as well. But it's still a super quick process, it seemed like, and efficient. But yeah, I'll have to reach out to them as well. It was definitely them. That a couple parts that came off their printer there, they looked pretty neat.
Cool.
Yeah, nice other connection again. We just keep finding different things.
Yeah, it's like the additive manufacturing world is growing exponentially, but especially within the carbon fiber space, I feel it's somewhat small. And you're going to Google like carbon fiber additive manufacturing, you're going to find a collection of things that it's not infinite.
Right. And most of which we've already talked about on this podcast. So well, yeah, I mean, thanks for sharing all that, Nicki. I know that you're also a busy CPO, certified prosthetist orthotist now, and you're off to see some patients today, right? So
actually won't be in the office today. We're a mobile clinic, so I'll be driving around to people's homes and facilities today.
Yeah, that's an interesting, patient care aspect to being mobile like that. I'm sure, and it's got its ups and downs, I'm sure, but kind of a unique experience.
Yeah, oh, for sure. And scanning is massively helpful when you're out in the field. And we use mostly the comb scanner on the iPhone, which is great because I keep it in my pocket. I'm not sponsoring them or anything. I actually truly enjoy having it on my phone. I find it to be very reliable. And yeah, it's almost exclusively a 3D model. I'm at Synergy Prosthetics, and it's based in Fremont, California. I cover a lot of the north and western Bay Area. But yeah, 3D makes a whole lot of sense to me for the mobile model.
For sure. You think we might be able to get a 3D printer in your van?
No, maybe someday.
We should try to
But
outfit
there's
one
a
and
whole
see
lot
how
of
it works.
castling going on back there, and those are expensive parts. So
Yeah,
definitely not right now. That would be cool though.
would be interesting to try to see how we could implement that. But
Yeah, I'll have to think on that one.
yeah, thanks for the time, Nicki. We appreciate you coming on today. If people want to reach out to Nicki here, she has worked with Ascent Fab in the past. You can reach out over email that way. Yeah, we could go on and on about some other involvements that Nicki has had. But Nicki, Nicki at ascentfab.com. You can reach out to her there, and we can chat more about her experience with 3D printing and being a certified prosthetist orthotist, utilizing it in the field. So thanks very much. Thank you everyone for listening. This has been an awesome Fabrication Friday podcast today, and looking forward to hearing what you think. So subscribe to the podcast. Look us up online at ascentfab.com and look at our LinkedIn site. Really posting a lot of cool stuff there pretty much weekly. So again, appreciate your time, everyone, and thanks, and have a good one.